A good day to all of you. I am very happy to talk to you about water technology today. I am going to give a very brief introduction about this topic. Let me introduce myself to all of you. This is Dr. V. Shubha, working as an assistant professor in chemistry, science and humanities, RMD Engineering College. Well, talking about water and its sources, we all know that water is the most important compound for the existence of human beings, animals and plants. More than 80% of the earth's surface is covered by water. Let us recall a few sources of water. This includes rain, rivers, lakes, wells, springs and seawater. Among the above sources, we all know that rainwater is the purest form of water, but it is very difficult to collect rainwater. Seawater is the most impure form, and we use seawater for most of the industrial purposes. It is very important to improve the quality of water that is being used because it contains a lot of contaminants and undesirable components. We can make this water appropriate for a number of specific end uses such as drinking, industrial water supply, irrigation and other uses. The process of removing all types of impurities from water and making it fit for domestic and industrial purposes is hence called water technology. Water treatment is the need of the hour. It also deals with the removal of specific impurities like calcium and magnesium salts that are present in water. The presence of calcium and magnesium salts are very harmful to industrial applications. So, based on the type of calcium and magnesium salts present in water, we classify water as hard water and soft water. Let us move on to what is called as hard water first. We all know that the water that does not produce lather with soap solution, but instead it can produce a white precipitate or scum is called hard water. Now, hard water is due to the presence of dissolved salts of calcium and magnesium. Let me tell a few salt names to you: calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, etc. Look at this equation. I have shown you an equation between soap and hard water. Let us assume that the hard water contains salts like magnesium sulfate as represented here. We see the product is magnesium stearate and sodium sulfate. Magnesium stearate is a white precipitate and insoluble scum that is formed in the reaction. The next one is about soft water. The opposite of what is hard water is soft water, of course. Water which produces lather readily with soap solution is called soft water. The soft water used is free from calcium and magnesium ions. It is not harsh on the skin, clothes or on dishes. Look at the equation that we are seeing for soft water. We see that lather is produced in the course of the reaction. Moving on to the next slide. This talks about hardness of water. Hardness is a property or characteristics of water which does not produce lather with soap. Now, how do we detect this hardness? Well, we shall move on to the next slide to know how hardness of water can be detected. Though there are many practical methods by which hardness of water can be detected, of course, reliable chemical methods are also available. Now, hardness is basically due to the presence of bicarbonates, chlorides and sulfates of calcium, magnesium and other heavy metals like strontium and iron. Based on the types of all these dissolved salts present in water, we can further classify the hardness of water into two important headings, and we call them as temporary hardness and permanent hardness. Let us move on to the first heading, temporary hardness, which is also called as carbonate hardness. Temporary hardness is basically due to the presence of dissolved bicarbonates of calcium, magnesium, heavy metals or bicarbonates of iron. Now, this temporary hardness can be well removed by simply boiling water. One of the simplest methods by which water treatment can be performed is boiling. The next one is about boiling water. The reaction is shown here. The bicarbonates get easily decomposed. They yield insoluble carbonates or hydroxides. They later get deposited as a crust You also call them as a scale, which is found at the bottom of the vessel. Carbon dioxide, a gas that is formed, simply escapes out of the reaction. The equation is represented here for a quick reference. Moving on to permanent hardness. As the very word represents, permanent hardness is hardness that is very difficult to be removed by simple methods like boiling. I would also say permanent hardness is called non-carbonate hardness. The permanent hardness is due to the presence of chlorides and sulfates of calcium, magnesium, iron and other heavy metals. As already told, this permanent hardness can be removed by chemical methods, especially by using softeners. And talking about the methods that are involved, the first one that I am highlighting here is called the lime soda process. The equation is shown there. And the next one is called ion exchange methods. We have two major methods that are getting discussed. The first one is called the zeolite process. You see the equation there, Na2Ze plus MgSO4 giving rise to sodium sulfate plus magnesium zeolite. Sodium zeolite is the zeolite that is used here. The second process is called demineralization process. The methods of removal of permanent hardness will get discussed under a special topic called demineralization, which will quietly follow after these topics get over. Now look at this, this is about the expression for concentration of hardness. We all know that calcium carbonate is going to be taken as a standard reference compound for expressing concentration of hardness. Now, why calcium carbonate is selected? This is a very important question, and to sum up, the first point that I would like to highlight here is because the molecular weight of calcium carbonate is 100, the equivalent weight being 50, which makes it very simple and easy for calculation. The most important second point, it is the most insoluble salt which can be precipitated in the water treatment very easily. The equivalence of calcium carbonate of a salt, let me represent it by a very easy formula. It says weight of hardness producing substance into 100 divided by the molecular weight of hardness causing substance. This is about the units of hardness. Now there are many units by which hardness can be represented. The simplest of which is ppm, parts per million, the most accurate in fact. The number of parts of calcium carbonate equivalent hardness present in 10 power 6 parts of water is what we call as ppm. The next one is milligram per liter. 1 milligram of calcium carbonate equivalent hardness present in 1 liter of water can be called as milligrams per liter. The third one is degree Clark. The number of parts of calcium carbonate equivalent hardness present in 70,000 parts of water can be called as degree Clark. And the last one is degree French. The number of parts of calcium carbonate equivalent hardness present in 10 power 5 parts of water. Thank you for your patient listening. I am very happy and glad that I was able to conclude this topic. Thank you again for your patient listening.